Hello class, these are our notes for Algebra 1. This is our Illustrative Math Algebra 1. We are in section 5.1. Today we're looking at growing and growing, so exponential functions. So the first question we want to consider for our notes is what happens when we repeatedly double a positive number. So here I have 1,000th, 0.001, and then we double it, we have 0.002, so 2,000ths. Let's see if we double that again. 2 times 2, doubling is really times 2, right? So if I multiply by 2 again, I would have 0.004. And then again would be 0.008. And then 0.0, when I double the 8, I get a 16. So I have 1,000th, if I'm reading them correctly, 2,000ths, 4,000ths, 8,000ths, and then 16,000ths. So we just keep doubling. So remember your decimal places. Your first place after the decimal is your tenths, and then your hundredths, and then your thousandths. So that's the way I'm trying to read them. It's kind of sloppy when we say 0.001, but it is a lot faster. Sometimes, though, we can't figure out what we're really talking about. So if we want to double the number 30 times, so that's kind of what we're thinking about now. Instead of doubling the number over and over again, we can use an exponent. So I'm going to go ahead and write exponent in here. Doubling a number is the same as multiplying by 2. So if I'm looking at my first thing in this table, 0.02, I took the 0.01 and I multiplied it by 2. So then I had to double it again. So I took that 0.001 and I multiplied by 2, and then I had to multiply by another 2 to get the next value, right? So this is doubling one time, so I have one factor of 2, and when I double it again, I'm multiplying by one more factor of 2. So I take what's already there and I multiply it by another factor of 2. So to get the 0.008, we could take what we had in the last step, 0.001 times 2 times 2, and we could multiply it by yet another 2. So what I'm trying to show is that for each of these, we're taking what was already there. So in my first step, I already had 0.001. So to figure out my second number, I would take that thing that I first had and multiply it by 2. And so here I'm going to take that last thing that I had and multiply by another 2. And now I'm taking that last thing I already had and I'm multiplying it by another 2 again. Okay, so for my last one, I would take what I already had, which is 0. Gotta erase this. I do not want to be using my highlighter. So if I think about what I had in my last step, well, in my last step, I already had the 0.001, and I had that multiplied by 3 2's already, and then I need to multiply it by yet again one more 2. So this is what I already had in the last step. That's equal to that 0.08, and then I have to do times another 2. Okay, so because we're multiplying by 2 over and over and over again, they're saying, hey, we could just use exponents instead. So if we want to double a number 30 times, it's the same as multiplying by 2 30 times. Okay, so here's our one time. We multiplied by one factor of 2. To get the second one to double basically 2 times, I had to multiply by 2 factors of 2. To get 3 times, I had to multiply by 3 factors of 2. And to get to 4 times the doubling, I had to multiply by 1, 2, 3, 4 factors of 2. How can we write this as an exponent? So I think, again, we need to probably break this down. I want to first look at, to get the 0.016, again, we had to take 0.001 and we had to double it 4 times. So times 2, that's the first time we doubled it, the second time we doubled it, the third time we doubled it, and the fourth time we doubled it. And we know that's the same thing as having 0.001 times 2 to the 1, 2, 3, 4 factors of 2 would be 2 to the 4th power. And if I do 2 to the 4th power on my calculator, I would get 16. So this ends up being 0.001 times 16, which is 0.016. So let's think about what happens if I want to have this 30 times. Well, that means I would have the 0.001 and I would multiply 2 a bunch of times. So many times I'm going to not write them all. I'm going to put some dots and show one in the middle. And then I'm going to do this over here and I'm going to write 30 factors of 2. So that means I would have 0.001 times 2 to the 30th power. And 2 to the 30th power ends up being a gigantic number, so I'd want to raise that to the power first, then multiply by the 0.001. And it turns out after we multiply this all out, we end up with something that's over a million. So I think what's so fascinating about exponents is we fill out this little table, and we're still looking at thousands, right? We're still looking at tiny fractions of a whole, and it doesn't seem like it's doing a whole lot. But then if we only double this 30 times, we have over 1 million. So it's really insane to me how fast exponents can grow. Over 1 million is what I meant to write. I don't know if you can hear my dogs wrestling in the background, but they're bumping into me. It's making writing a little bit interesting. They like to come in and keep me company while I make math videos and wrestle. So write an equation to double 0.001 x number of times. So if I wanted 30 times, remember what I had to do is I had to write 0.001 times 2 to the 30th. So that's for the 30 times. So if I want to do x times, I'm going to have to write 0.001 times 2 to the x power for x times. So applying the same factor repeatedly is done through exponents. That's the heart of what we're doing today. So the big takeaways from today are this idea that instead of multiplying something over and over and over again, we can use exponents as a shorthand way to express that. So as always, if you have questions, please make sure you ask.